This is Udumat. Today I want us to look at this not drawn to scale football pitch. Okay, it's not drawn to scale. So let's consider line A, B, C, D bordering this football pitch. Okay, now when players are on the pitch, let's say this is the ball. Okay, the ball can move towards the line, but it shouldn't cross. So the limits that the ball can go is on the line. It can't cross. The moment it crosses, there should be a restart. Okay. Now the ball can be on all inside, and also can be on the line, on these lines. But the moment it crosses, then there should be a restart. Okay. So the ball can be on the line, that is equal to whatever it's on the line, or the ball can be approaching the line. So we are going to start our discussion today on limits. And limits is under calculus. And calculus has been divided into differentiation and integration. So let's see how we can apply limits calculus. Okay, so we are looking at calculus. And I said calculus is divided into two main groups, that is differentiation and the other one is integration. So we are starting from differentiation. Then after, when we are done with all subtopics under differentiation, then we'll go to integration and look at what is happening there also. Now, we are starting from limits of functions. Limits of function. And we normally say the limits of the function f of x as x approaches a certain value, or let me say approaches 0, is written by the limits of f of x as x approaches 0. And this can be any value. The limits of function f of x as x approaches a certain value, let's say approaches 0. So I told you it can be equal to 0 or approaching 0 or just approximately equal to 0. Okay, so like I use the football pitch where I said the ball can be on the line or in between the lines. If you go outside the line, then there should be a restart. Okay, so it can be 0 or approaching 0. Okay, so the limits of the function f of x as x approaches a. That is how it's supposed to be read. Now, this is found by replacing x by a in the function given. Okay, so the example is, let's say we have limits of function f of x as x approaches, let's say 2. So it means that wherever you see x, you put 2 there. Okay, now let's look at some limits of functions. Now, if f of x is equal to k, we are looking at limits of constant functions. So if f of x is equal to k, then it means the limits of f of x as x approaches k is k. Okay, so that is the limit of constant function. Another one, so let's say limits as f of x, or limits of f of x as x approaches 2 is also 2. So that is the limit of constant function. So like I said earlier, we are just replacing x by a. So if f of x is equal to 2, then it means limits of f of x as x approaches a is equal to 2. Okay, so let's look at the next function. So now let's look at limits of polynomial function. Limits of polynomial function. And before that, let's define polynomial function. So polynomial function is given by f of x equals a sub 0 or a naught x to the n plus a sub 1 x to the n minus 1, then a sub 2 x to the n minus 2 plus plus a to the n, a sub n minus 1 x to the power 1. Then so this is how polynomial function is. Okay, now the limits of polynomial function as now with this a sub a naught, a sub 1, a sub 2, a sub n minus 1, and then a sub n. These are all constant functions. These are constant functions. Okay, now let's look at the limits of polynomial function. So example, if f of x is equal to 2x squared plus 3x minus 5. Let's find the limits as x approaches. So if f of x is equal to 2x squared plus 3x minus 5, Then the limits of f of x as x approaches -2 will be equal to, that is, we are going to replace or substitute -2 for x, or when we see x we put -2 there. So that is going to be 2 into -2 squared plus 3 into -2 minus 5. So this is going to be 4 times 2, 8, plus this is also -6, so minus 6, and then minus 5, and that becomes, so this is -11 plus 8, or 8 minus 11, that is -3. So this is all about polynomial functions, limits of polynomial functions. Let's look at one more example. So let's look at this example. If f of x is equal to 3x squared minus 5x plus 6, then the limits of f of x as x approaches -1 becomes 3 into -1 squared minus 5 into -1 plus 6. So we said when we see x, we put -1 there. Okay, so this becomes 3, this is going to be positive 1, then 3, so minus, and this becomes plus 5, so plus 5, plus 6. So that is going to be 14. Okay, so let's go to the next limits. Okay, so now let's look at limits of rational functions. And what are rational functions? Rational functions are functions of the form f of x is equal to h of x over g of x, where h of x is not 0 and g of x is also not 0. Okay, so let's look at an example. And if h of x and g of x are 0, what you do is reduce it to its simplest form. You reduce the function to its simplest form, then you continue with that. So let's look at these two examples. The first one, we are told to evaluate the first one, a, limits as x approaches 2 of x squared minus 7x plus 10 all over x squared minus 4. And then b, limits as x approaches 9 of this function, 9 minus x over 3 minus root x. Okay, so let's take them one after the other. So let's look at the first one. Now, this one, all that we can do is to take the numerator, that is x squared minus 7x plus 10, and then resolve it, or maybe find the factors. Then after we put it here to see what is going to, then after we take this one and also find the factors also, or resolve it. Okay, so x squared minus 7x plus 10, here, let me equate this to 0. Okay, or we can decide to, let me just solve it as is. So here, we multiply this 1 and this 10. So we are going to get 10. Factors of 10, we have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus, and then 10 itself. Okay. So we take two numbers that can fit here, but when you multiply, we should get this 10. So I can take 2 and 5. So which one is going to be negative? If I use negative and negative 2, negative 5, that will give me negative 7. Then when I multiply negative 2 and negative 5, that is going to give me positive 10. So it means I can choose negative 2 and then negative 5. So x squared minus 2x minus 5x plus 10. Okay, so that is the negative 2 and then the negative 5. This is going to give me negative 7. But when I multiply them, I'm going to get 10 without the x. Okay, so here we have x being common to these two. So x is out, x minus 2 is what we have here. Now this side too, 5 can divide 10 and itself. So minus 5 out, x minus 2. So let's see. This side, this is going to give me negative 5. When I multiply this and this, I'm going to get positive 10. So those outside brackets, that is x minus 5. And then those inside brackets, we have x minus 2. Okay, that is for the numerator. So let's look at that of the denominator, which is x squared minus 4. And we can rewrite this as x minus 2, then x plus 2. So that is difference of 2 squared. This is the same as x squared minus 2 squared. And when we have this, that is how we can resolve it, or we can break it. So this will give me this. Now let's put this one and this one into the question. So here I've replaced the first one, which is x squared minus 7x. So I've replaced the x squared minus 7x plus 10 by the factors we had. Then x squared minus 4 by also 8 factors. Okay, so now let's see. Since this and this are multiplying over this also multiplying, we can take care of this one. Okay, so we have the limits as x approaches 2 of this function x minus 5 over x plus 2, so x plus 2. Then from here, what we need to do is, then we just substitute 2 for x, or when we see x, we put 2 there. So this is going to be 2 minus 5 over 2 plus 2. And this is negative 3 over 4. So the answer is negative 3 over 4. Okay, so for the second one, we have the limits of 9 minus x over 3 minus root x as x approaches 9. So let's see how we can do this. Now, because of this root x, and then 3 minus root x, because of this root x, what you're going to do is to rationalize the denominator. So that is multiply the numerator and the denominator by the conjugate of the denominator. And the conjugate of 3 minus root x is 3 plus root x. So we are going to multiply the numerator and the denominator by this. So here we have 9 minus x to multiply 3 plus root x over 3 minus root x, also be multiplied by 3 plus root x. Okay, so then here, let's expand the denominator. So we have 9 minus x and then 3 plus root x divided by, so this and this, we are multiplying. This and this becomes 9, then this and this becomes plus 3 root x. Then negative root x times 3 is also minus 3 root x. Then negative root x times root x becomes minus x. Okay, so 9 plus 3 root x minus 3 root x, this will be 0. So we get 9 minus x. So the answer here we have 9 minus x and then 3 plus root x all over 9 minus x. Okay, now from here we can, this can take care of this one. So this and this will go away. So we have 3 plus root x as what we have, what is remaining. So now let me invite the limits. So the limits of 3 plus root x as x approaches 9. So from here, what I need to do is just to, where I see x, I'll put 9 there. So this becomes 3 plus root 9 over, so that's all, 3 plus root 9. And this is going to be 3 plus 3, because root 9 is 3. And the answer is 6. Okay. Let's go to the last of the limits. The last two of the limits. Okay, so now let's look at limits involving infinity. Now the limit of f of x as x approaches infinity or become very large is denoted by the limits of the function f of x as x approaches infinity. Okay, so when we have something like this, let's take an example and see, or let's take some take a look of some characteristics here and see how we can use it to resolve the question under this one. Now let's take note of the following. So limits of 1 over x to the power n as x approaches infinity is 0 if n is, so if n is positive or greater than 0, if n is positive, then limits of x to the power n as x approaches infinity does not exist if n is positive again here. Now, if f of x is equal to g of x over h of x, then the limits of f of x as x approaches infinity can be found by dividing the numerator and the denominator by the highest power of the variable in the question. Okay, so let's take an example and see how we can go through some of these limits. Okay, so now let's look at these two examples. So the first one says the limits of 2x cubed minus 7x plus 3 all over x cubed plus 2 as x approaches infinity. And then the limits of 5x squared minus 1 over 2x squared plus 1 as x approaches infinity. So let's see how we can use two examples. Okay, so here we are told, or we are told to divide through by the highest power of the variable. And the variable here is x. The highest power is this with the power 3. So this is going to be the limits as x approaches infinity. So that is 2x cubed over x cubed, and then minus 7x over x cubed plus 3 over x cubed all over x cubed over x cubed plus 2 over x cubed. Okay, so this is going to be the limit as x approaches infinity of, now this and this will go out, so that is going to be 2, because this will cancel this one. Then here this will be 7 over x squared, so minus 7 over x squared, then plus 3 over x cubed divided by 1, here will be 1, plus 2 over x cubed. Okay, so now let's continue from here. So the limits as x approaches infinity. So as x approaches infinity, that is, as x becomes very large, what happens to these figures? So it means that if this is becoming large, we are going to have something that will be approaching 0, or that will be getting close to 0. So we can put 0 here and then put 0 here. Okay, because if I divide this by, let's say x is becoming, let's say 2, then it will be 3 over 8. So 3 over 8 will make this to be approaching. If I make it 4, then to be more closer to 0 than. Okay, so as x approaches 0 here, we just need to put 0 here. So that is going to be 2 minus 0 plus 0 over 1 plus 0. Okay, so this is going to be 2 over 1, which is 2. Because as x becomes large, this will just be closer to 0. The same thing applies to this one. Okay, so let's look at this second example. So now, like we said earlier, when you have something like this and x is approaching infinity, so what we need to do is divide both the numerator and the denominator by the highest power of the variable. So here we have limits as x approaches infinity, and that is going to be 5x squared over x squared, then minus 1 over x squared, divided by 2x squared over x squared, plus 1 over x squared. Okay, so this is going to be 5 minus 1 over x squared all over 2 plus 1 over x squared. Okay, so limits as x approaches infinity. Okay, now when this happens, as x becomes large, these things will be approaching 0, so we can put 0 in place of these terms. So that is 5 minus 0 over 2 plus 0, and the answer becomes 5 over 2. In that sense, we can say this is 2 whole number 1 over 2. Okay, so that is that.